Where in the vicinity of Earth is there an ocean where swimming is deadly dangerous, where winds blow at speeds far exceeding the flight of the fastest airliners on our planet, where hurricanes rage that surpass the size of those on Earth? Those who are familiar with the topic of space have already guessed that we're talking about Jupiter. This gas giant could have become a star, but it's a bit too slim. If it were about 50 times heavier, there would be two parent stars shining in our sky, one of which would be a brown dwarf. Who knows what life on Earth would look like then? Come on. No wonder astronomers have long been fascinated by Jupiter. It's not just a big planet, it's like a regional rescuer, a vacuum cleaner that catches most of the comets, meteors, and asteroids that occasionally enter the solar system. The most epic recorded impact in the history of Earth-based observations was the Shoemaker-Levy 9 comet, which crashed into Jupiter in July 1994. A tailed guest from Donbass, that's really unlucky. The monstrous tidal forces of the gas giant broke it into 21 fragments each, about 2 kilometers in diameter, which stretched out in a fan over 200,000 kilometers long. When the fragments of the failed traveler fell into the turbulent embrace of Jupiter's atmosphere, only a few miserable brown spots remained on the face of the planet, like the collision of an ant with a mammoth. But that's not the only remarkable thing about Jupiter. Nominally, the planet doesn't have a surface, so if a shuttle tried to land on Jupiter, it wouldn't be able to do so. After all, the planet is essentially a boundless ocean of gas, permanently in a state of storm. Then maybe it could dive into this deadly ocean. That is, fly through the planet. That wouldn't work either, because in that case, the shuttle would be crushed in a matter of seconds like a rusty tin can, and then melted by sulfur compounds. So what's inside Jupiter, and why is it dangerous to even approach it? To find this out, in late summer of 2011, National Aeronautics and Space Administration launched the automatic interplanetary station Juno to Jupiter. 5 years later, it began its mission and became the second spacecraft after Galileo to closely study the gas giant. Juno has been successful from the very beginning. There hasn't been a single maneuver or equipment activation that has failed. Besides studying Jupiter, Juno has also explored the areas near many of its moons. A photo of Ganymede was taken for the first time in 20 years. The only part of the mission plan that has not yet been carried out is deorbiting the probe in 2021. Juno was collecting data so actively, literally working to the limit, that it was decided collectively to extend the mission until 2025. The scientists also thought it would be a good idea to study the Galilean moons in more detail during this time. As part of the program, Juno is expected to approach Europa at a record 320 kilometers and examine the mysterious stripes and icy ridges on its surface. It will also come within 1,000 kilometers of Ganymede and 1,500 kilometers of Io. What news about these celestial bodies can humanity expect in the future? The answer to that question is still unknown. However, the probe will measure the thickness of the ice beneath Europa's ocean and create a detailed high-resolution map of its surface, as well as take a close look at the other moons. Naturally, everything that Juno transmits is automatically compared with the materials received from Galileo. This way, the information is refined and corrected. In the meantime, let's find out what Juno has discovered on Jupiter and what secrets its atmosphere holds. This is the largest gas envelope around a planet in the entire solar system. It mainly consists of hydrogen and helium like our Sun, but it also contains other compounds. Is there a division of the gas giant's atmosphere into levels or layers? Yes, and their names are similar to those on Earth, but that's where the similarity ends. For example, without a solid surface, the planet's lower atmosphere gradually merges into the hydrogen mantle. There are no clear boundaries between the Jovian layers. After all, the pressure here is so immense that hydrogen and helium turn into supercritical fluids, whose properties combine characteristics of both gas and liquid phases remotely. It's similar to the gradual transition of the exosphere into interplanetary space at 5,000 kilometers above Earth. Above Jupiter's troposphere lies the stratosphere, then the thermosphere, where the conditions are truly immense and hellish. At 1,000 kilometers in the thermosphere, the temperature is 1,000 kelvins, and the pressure is 1 nanobar. In general, Jupiter's atmosphere is like a multi-layered sandwich or a festive cake. The huge number of layers, mixing with each other and constantly swirling, can be clearly seen in the photos provided by Juno. But don't let the brightness and festive appearance mislead you. It's a deadly cocktail of poisonous gases: ammonia, methane, hydrogen sulfide, phosphine, sulfur, nitrogen, krypton, xenon, argon, and diacetylene. The very top layer of clouds is made of ammonia ice, gradually transitioning into ammonium hydrosulfide. By the way, scientists still have no idea where such bright colors in Jupiter's atmosphere come from. However, the most amazing sights Juno observed were at Jupiter's poles. Numerous storms in the form of vortices and cyclones are both a beautiful and frightening sight, especially in the infrared range. That was the North Pole, and here is the South Pole. As they say, fine 10 differences. What do the storms shown in the photos remind you of? It seems as if the ocean of ever-boiling lava is starting to boil. Besides the layers, Jupiter has a unique phenomenon called jets. They are what create the bands and the smoky structure of its atmosphere. The wind speed in such areas reaches 100 meters per second. These are incredible numbers. Why is the atmosphere of the gas giant so turbulent? And what exactly sustains all this chaos and commotion? One theory suggests that Jupiter's internal heat is to blame, left over as a result of heating during the early stages of its formation. So essentially, the giant is a titanic thermostat in which convection processes are constantly taking place. Undoubtedly, the most epic phenomenon in Jupiter's atmosphere is the hurricanes, which can be seen even from Earth, let alone from aboard Juno. There are hundreds of them, and such vortices can live from several days to entire centuries. Here is a fragment of Jupiter's atmosphere captured by Juno in August 2020. In the image, you can clearly see how dynamic it is. It's not just a single calm area. It's no wonder with such a high rotation speed, a day on Jupiter lasts only about 10 hours, and this brevity is more than compensated by a year that lasts almost 12 Earth years. As you know, Jupiter's atmosphere is the place where the Galileo probe found its final resting place. A similar fate awaits Juno as well. When Galileo made its final descent, it managed to transmit a lot of interesting information about the gas giant's atmosphere, for example, about its temperature changes. The very top layer of clouds has a pressure similar to Earth's and a temperature of about minus 100 degrees Celsius. But if you go down about 150 kilometers deeper, the pressure rises to 22 atmospheres and the temperature goes up to plus 150 degrees Celsius. Beneath the surface clouds, there is a layer up to 25,000 kilometers thick, which is dominated by metallic hydrogen. This element enters such a state under supercritical conditions when the pressure reaches 1,000,000 atmospheres and the temperatures go beyond what is possible. It is exactly these favorable conditions that occur in Jupiter's atmosphere. Metallic hydrogen conducts electricity excellently, so anything that ends up in this extreme layer is in for an unpleasant surprise. If it hasn't already been melted by acids, the electricity will definitely kill it. When talking about hurricanes, we can't ignore the Great Red Spot. Astronomers have been observing it since the mid-17th century. During this time, the size of the hurricane has changed, becoming smaller, but even now, the Earth could easily fit inside it. Previously, this was believed to be a solid structure, not a storm. However, the Voyagers resolved the issue and corrected the mistake. What information about the Great Red Spot was first transmitted specifically by Juno? The probe, having approached Jupiter, measured the depth of the hurricane, which turned out to be between 240 and 500 kilometers. Despite the fact that the Great Red Spot tends to shrink, it is still the largest vortex in the solar system. This is how it looks from aboard the Juno spacecraft. An interesting observation. Jupiter's atmosphere is entirely made up of vortices, but the most stable ones are located in the southern hemisphere. And here is the Great Red Spot, captured by the probe in close-up. Sometimes hurricanes in Jupiter's atmosphere, with speeds higher than any storm on Earth, collide with each other. This is truly an epic event. For several years, the structure and color of the colliding vortices can change. Sometimes, as a result, a new, much larger vortex forms. A true miniature merger of galaxies. If you add lightning to this, stretching over 1,000 kilometers and 3 orders of magnitude more powerful than those on Earth, you get a truly chilling picture. Scientists began to wonder why some hurricanes, like the Great Red Spot, persist in the atmosphere for so long and why they don't disappear. One theory is that Jupiter doesn't have a solid surface because it's the solid surface on Earth that calms storms down. By the way, besides the bright hurricanes, Jupiter also has so-called white ovals. Most likely they form according to the same laws, but they look like this. They also last a very long time, literally for centuries. A pressing question that has interested scientists for decades is whether Jupiter has a core. What about the measurements taken by Juno? They say that it does exist, and its mass is about 10 times that of Earth. It is this core that generates the anomalous amount of heat mentioned earlier. Now the question is, what is Jupiter's core made of? According to some paleontologists, it contains a significant amount of diamonds in the form of molten droplets. How did they get there? Carbon soot turning into graphite, then transforms into diamonds, and as they heat up and move closer to the core, they settle on it as liquid droplets. How do you like that, Stephen Hawking? It's a pity that Juno is unlikely to reach the core on its final flight to test this exotic theory. For dessert, here's another fact to ponder. What happens on Earth in those areas where a shadow falls, no matter if it's from trees, houses, or clouds, right? In that place, it becomes noticeably cooler, but not on Jupiter. The area is covered by the shadows of its many moons. Instead of lowering the temperature, actually raise it significantly. The nature of the appearance of hot shadows hasn't been studied at all. That's our neighbor Jupiter, with incredible auroras and deadly lightning, monstrously fast hurricanes, and supposedly a diamond core, dozens of moons, and hot shadows from them. At one of its poles, there is an unknown source of hard X-ray radiation, discovered by the Chandra telescope, and still remaining a complete mystery. Even probes are at risk when approaching Jupiter to avoid total equipment failure. For example, Galileo received a dose of radiation during its approach that was 25 times higher than the lethal dose for a human. This is an absolutely alien and hostile world to us, which nevertheless attracts us with its undiscovered mysteries. While our planet is shaken by treacherous geopolitics, science does not stand still and once again changes the established understanding of the relatively studied worlds of the solar system. For example, did you know that life on Jupiter's moon, Europa, can be found without trying to drill through kilometers-thick layers of ice? Do you know what exactly Saturn is hiding from us beneath its gaseous shell? And are you still sure that Saturn has just over 80 moons? The answers to these questions can surprise and even bewilder you, because soon we'll have to rewrite astronomy books and reconsider many facts we were absolutely sure about. So let's start with Jupiter's moon Europa. What has it done recently to surprise scientists? It's no secret that on October 14th, 2024, the automatic interplanetary station Europa Clipper was launched. Its mission is to closely examine Europa's surface, and most importantly, to try to find signs of at least the simplest forms of life. It's noteworthy that the closest approach between Europa Clipper and the Moon itself will be a record-breaking 25 kilometers. This means that the probe will examine the surface of the celestial body almost as if under a magnifying glass. This has never occurred in any prior mission. But why Europa? It is even known that life on Earth originated in water and at a considerable depth. So where else should we look for alien forms of life if not on the Moon with the most impressive ocean in the solar system? The existence of an ocean beneath Europa's massive icy shell has been considered for a long time. There is both direct and indirect evidence of this. For example, you may have noticed that compared to our Moon, Europa's surface is pristine and smooth, almost without any signs of craters, whereas the Moon has a lot of them. Do you really think meteorites have intentionally avoided Europa for billions of years? Of course not. Most likely, geological activity caused by the enormous subsurface ocean, which is at least twice the volume of Earth's, as well as the proximity to Jupiter with its hellish tidal forces, constantly deforms the icy surface of the Moon. That's why old craters are gradually erased, as if by an eraser. By the way, the fact that at least some craters remain on Europa's surface is very helpful to scientists. It's a kind of window into the subsurface ocean, because craters can be used to roughly estimate the thickness of the icy crust above this global body of water. Researchers estimate it ranges from a few to several dozen kilometers. And here we've come to a very important point, one that is specifically assigned to the Europa Clipper mission. How long do you think it will be before we can drill through Europa's icy shell? Most likely. That's according to the most optimistic forecasts. But astrophysicists have found a more ingenious way to obtain information about the composition of the subsurface ocean of Jupiter's moon. Considering the history of life on Earth, the first molecules fed on minerals and other useful substances produced by underwater vents. Even now, this phenomenon still exists. Think of the black smokers in the Atlantic Ocean. So by analogy, we can assume that something similar could also occur in Europa's ocean. How will we test this hypothesis? The fact is, one of the pieces of evidence for the existence of Europa's subsurface ocean is the geysers that periodically appear above the moon's surface. The rapid bursts of water vapor, recorded by several spacecraft, come from beneath the icy crust, breaking through its cracks. What could this mean in practice? And here's the thing, Europa Clipper, by flying through one of these plumes, will be able to collect enough material to study the composition of the subsurface ocean. It may well turn out that there are also organic molecules in it, the so-called building blocks of future life. Overall, Europa is an excellent platform for understanding the processes of the origin of life and a target for studying potential habitability due to the presence of liquid water. Moreover, a close study of this moon will help shed light on the laws by which Earth developed, since astrobiologists believe that Europa is similar to our planet in the early days. However, let's go back to where it all began. What new insights about Europa have emerged as a result of recent research? They concern tectonic processes on Jupiter's moon, specifically the movement of the icy crust. Previously, it was believed that global ice ridges move and completely reshape Europa's surface. But according to new data, that's not entirely the case. Astronomers believe that only the upper layers of ice are mobile, and they are moved by Jupiter's tidal forces. The ice crust as a whole is immobile, OK Sphinx, and keeps the subsurface ocean in absolute stillness. By the way, why do scientists think that the ocean on Europa is warm? It turns out that this is facilitated not only by tidal deformations coming from the giant gas neighbor. There is a hypothesis about certain Rossby waves. These are so-called traveling waves that form in the ocean's atmospheres due to the tilt of the celestial body's axis. This parameter is still not exactly known for Europa, but there is reason to believe that it reaches 0.1 degrees. If that's the case, then the energy of Rossby waves could be 2,000 times greater than that of tidal deformations. Thus, this phenomenon could become the main source of heat for Europa's ocean. When will we learn about all this? We'll definitely wait until 2030 and observe the exploration of Europa Clipper. In the meantime, let's turn to one of our space giants, Saturn. What new things have we learned about it using probes and telescopes? First of all, Saturn's rings, without which people on Earth can't imagine the planet's appearance, will disappear relatively soon. And not because Earth will be in the same plane with them in 2025. That's just a visual effect based on computer modeling. Astronomers are certain of this, especially planetary scientist James Adonakyu from the Japan Aerospace Exploration Agency. There are no more than 300 million years left for Saturn's rings. That's literally a moment by the standards of the universe. But for what reason could they disappear? It's all about precipitation. About 2.8 tons of precipitation in the form of hail falls on Saturn every second. This was reported by the Cassini spacecraft's research and later confirmed by James Webb, which is the latest of these findings. Of course, with some simple calculations, we can say with relative accuracy that at this rate of material loss, Saturn's rings could really disappear within a range of 100 to 300 million years. But there is a faint hope. The method of measuring the rate at which the ice from the rings disappears into Saturn's gaseous haze can't be called highly accurate, so they might evaporate even after a billion years. But the very fact of their disappearance is not disputed, since it's unlikely that the process of hail falling onto Saturn will stop. Do you want to hear another piece of news about our ringed neighbor that will overturn what we thought were unshakable facts about this planet? We're going to talk about the number of Saturn's moons. Back in 2019, 82 moons were known, discovered at different times by various probes like Cassini and Voyager. However, 2023 turned out to be a very fruitful year for discovering new satellites of the giant. As of the end of May 2023, Saturn has 146 natural satellites. However, only 63 of them have proper names, while the rest are still listed by numbers in the catalog. Accordingly, Saturn has become the undisputed record holder in the solar system in terms of the number of satellites. However, this does not change the fact that Titan is Saturn's largest moon, and it is on Titan that scientists suspect the hypothetical presence of life. What are these assumptions based on? At first glance, Titan is quite a cold and inhospitable place. Its surface has many methane and ethane lakes, rivers, and seas. The rains on Titan also consist of ethane and methane. Life seems impossible in such a harsh place, yet Titan's atmosphere is full of organic compounds. Scientists suggest that life could develop in the upper layers of the atmosphere, which, by the way, are rich in hydrogen. Titan is also suspected, like Europa, to have a subsurface ocean. This celestial body is generally thought to resemble Earth's conditions from 4 billion years ago. Unfortunately, the rest, especially the newly discovered moons of Jupiter, do not have such promising characteristics. Mostly they are small and sometimes even tiny bodies made of rock and ice. The last object discovered was designated S2006-S20 with a diameter of 5 kilometers. It orbits Saturn in 567 Earth days. Are these really all the new discoveries concerning the gas giant? The most amazing thing scientists are trying to uncover about Saturn is hidden deep inside it? Yes, you're not mistaken. This unusual core was believed to be relatively small and made of ice or rocks. But the analysis of data obtained by the Cassini spacecraft suddenly revealed some different information that astonished astrophysicists. Have you ever seen soup sloshing around in a bowl? The core of Saturn is in a similar state permanently. It is diffuse, meaning it exists in both liquid and solid states at the same time due to the immense pressure and extremely high temperatures. It is also oversaturated with hydrogen and helium, and the diameter of the core is about 70,000 kilometers, which is roughly 60% of the planet's diameter. Because Saturn's density is lower than water, New information shows that if a big enough pool existed, the planet could float in it. It completely overturns all our ideas about the formation of gas giants, and in the long run, it significantly changes what we know about the nature of exoplanets. How did scientists obtain this sensational information? Christopher Mankiewicz and Jim Fuller, astrophysicists from the California Institute of Technology, were able to clarify information about the structure of Saturn's core thanks to a study of Saturn's rings. It was the oscillations of the rings that allowed them to supplement information about the planet's structural composition. This can be compared to the work of terrestrial seismologists, who use earthquakes to study the Earth's interior. How does the mechanics of this process work? Saturn's rings are divided into several sectors based on their proximity to the planet. The C ring is the closest to Saturn, so its oscillations have been crucial in research. As a result, it was discovered that the planet's core contains an incredible amount of helium and hydrogen, equivalent to 55 Earth masses, which in turn makes up half of Saturn's mass. That's the complete list of significant discoveries for now, but we're confident that Europa Clipper will lift the veil on cosmic mysteries and open up new opportunities for us. What do you think the probe will be able to discover on Europa? And how will it change our lives? We're also taking bets on when Saturn's rings will disappear. Will it be in 100, 200, 300,000 years? Or will we have to wait a whole billion? Suggestions and hypotheses are welcome in the comments. The universe is vast and amazing, that's undeniable. But do you know what the most striking trait of modern humanity is? It loves to try to look deep into the macrocosm, stubbornly ignoring something amazing that's right here in our own solar system. That can be said about many relatively nearby objects, but not about Io. Astronomers have long studied this Jovian moon. How could they not notice it? It's a real fireworks show, not a satellite. What do you think would happen if Io were in place of our moon? First of all, every time people looked at the sky, they would enjoy the sight of a 24-hour disco, and although Io is similar in size to our moon, we would notice the switch instantly. Why? The first and main reason is that Io is the most geologically active celestial body in our solar system. If you take a close look at the satellite using infrared filters, it becomes truly frightening. Most likely, this is what believers imagine biblical hell looks like. It seems like lava is flowing, volcanoes are raging, and the ground is splitting open on literally every square kilometer of the celestial body. It's the perfect time to torture unrepentant sinners. Indeed, there are more than 400 active volcanoes on Io, by the way, going back. Our moon doesn't have a single geological one. And not because Io is very far away, but because the impressive geological activity of the satellite is caused by its proximity to Jupiter, right next to Earth. The picture would change radically. Astrophysicists believe that it is the tidal gravity of Jupiter, Ganymede, and Europa, Io's closest neighbors. That leads to the regular boiling of the moon's interior, which is forced to erupt through volcanic vents. In other words, the celestial body is literally being sick. The traditional question is, how do we know all this? Such information has been shared with humanity not only by telescopes, but also by numerous missions flying past Io. Jupiter's moon was first briefly observed by the Pioneer probes in 1973-74 and also by the Voyagers. By analyzing the mosaic of images sent by the probes to Earth, some preliminary conclusions were made. Namely, the surface of Espiritu O is completely covered with high mountains, many of which are taller than Everest. The moon has a huge number of volcanoes, and lava rivers flow from them for 500 kilometers or more. It also became clear that the surface of this unusually active celestial body is relatively young, since no craters left by asteroids and meteorites have been found on it. Besides the Pioneers, the Voyagers, Galileo, Cassini, Huygens, and New Horizons also observed Io, following the Voyagers in exploring the vicinity of Io. The Galileo probe visited in 1995. There were high hopes for it, but due to equipment failure, the mission nearly failed. However, despite the limitations in obtaining visual data, Galileo still made many discoveries and took many photos. In particular, the probe witnessed an incredible eruption and found out that Io has an iron core without signs of convection, since the moon does not have its own magnetic field. Cassini and New Horizons, while flying near the celestial body, like the other probes, recorded plumes from volcanic eruptions and observed the development of events as much as possible. I wonder what a person would see on Io if they decided to travel to Jupiter's moon. As we near the celestial body, drifting like a grain of sand before Jupiter, we notice how distinct Io is from other objects. Even from a distance, the moon looks unusual, completely covered with colorful spots, sharp mountain peaks, strange ravines, and channels through which molten lava flows. So what will an astronaut encounter first as soon as he gets up close? What is it? Titanic doses of radiation? He probably won't have time to admire the volcanoes, because in just a few hours, he'll receive a year's worth of radiation and get radiation sickness. What else can cheer up a weary traveler on Io? This celestial body has a thin atmosphere made of sulfur dioxide with a hint of sodium chloride. Obviously, breathing this mixture without special equipment is unthinkable, especially considering that volcanoes erupt here all the time. It's quite cold on Io, about minus 143 degrees Celsius. In such conditions, lava cools quickly, turning into something like obsidian. Hello, Minecraft fans, so what about the landscape? Now that will truly amaze a traveler with its diversity. As mentioned earlier, astronomers did not notice any impact craters on IBUSO, unlike the ancient moon or Mars. However, there are many mountains here, and according to recent data, not all of them are volcanoes. There are about 150 mountains on Io with an average height of 6,000 meters, but some reach up to 18 kilometers. Of course, this is not the Martian Olympus Mons, but still much higher than Mount Jamalungma. Do you know what interesting feature caught my eye? First of all, when scientists studied images of Io with mountains depicted, no mountain ranges or chains were observed on the surface of the satellite. Mostly these are isolated objects. There are also questions about the shape of some peaks. They are unnaturally elongated and pointed. On Earth, such configurations are extremely rare, for example. Mount Toko, nearly 9 kilometers tall. With a diameter of about 430 kilometers, it has the most geologically complex structure in the entire solar system. And South Bausavla, at 18 kilometers high, has the most impressive cliff among all the mountains in our star system. Its southeastern slope reaches a height of 15 kilometers. That's the place where, if you take a running start and jump off the cliff during flight, there's a real chance you could die from the impact on your feet. But what types of landforms are most commonly found on Io? These are paterae, extremely deep craters with very rugged shapes. There are quite a lot of them on Jupiter's moon, and notably these craters are not empty. They contain sulfur lakes where an astronaut would hardly want to take a dip. For example, Patera. Loki, one of the largest on Io, has a diameter of 250 kilometers. The caldera is filled with cooling lava with small islands sticking out on the surface. Back in 1979, during the flyby of one of the Voyagers, it was discovered that the temperature of the liquid in Loki's lake reaches about plus 8 degrees Celsius. That might seem quite comfortable to you, but don't be fooled. The probe likely caught the lava while it was cooling, since when the volcano is active, its temperature is hundreds of times higher. This is clearly visible in the infrared image. By the way, later in 2023, this same Patera was photographed by the Juno mission, which is currently exploring Jupiter and its surroundings. Relatively close to Loki Patera, there is a similar formation called Amaterasu Patera. Its distinctive feature is that between missions, the sulfur lake, which is 100 kilometers in diameter and located in the crater, has darkened significantly and now holds the spot as the darkest area on Io. The reasons for this phenomenon are unknown, but the Patera that has been studied best by Earth probes is Tvashtar Patera, which is located in a very active volcanic region. Galileo studied it quite thoroughly and once recorded an epic eruption accompanied by a gas plume that rose almost 400 kilometers above the surface of Io. A few years later, the same event was photographed by New Horizons as it flew past Jupiter on its way to Pluto. Patterns on Io, as if they are competing with each other for the title of the most outstanding. For example, the Patera, named after Ra. The Egyptian sun god could very well take the place of the object that created the largest lava field on Jupiter's moon. This is an active volcano only 1 kilometer high, but the consequences of its activity spread out for hundreds of kilometers around. Which landscape feature of Io would you like to highlight in particular? This is the Pele volcano, named after the Hawaiian goddess of volcanoes, not the football player. Why did we single it out among such a huge number of volcanoes on Io? The fact is, it was from the plume caused by the eruption of the Pele volcano in 1979 that Voyager 1 detected the process of active volcanism on Jupiter's moon, which has been studied continuously ever since. You can't confuse this volcano with any other, even when looking at Io from afar. It is surrounded by a huge brown ring, about 1,200 kilometers in diameter, formed by sulfur deposits that appear after impressive eruptions. Within the boundaries of Terra Pele, there is also a lava lake, measuring 20 by 30 kilometers. If you think the surface of this exotic body of water is calm and peaceful, you're very much mistaken. Inside it, subsurface molten rocks and sulfur dioxide from the atmosphere are constantly mixing. In the infrared spectrum, this lake always glows brightly, just like many other locations on Io. The temperature of the substance filling this lava lake is about 1,300 degrees Celsius. It's hard to imagine what a diver's wetsuit would have to be made of if someone dared to dive into its waters. That's what Jupiter's moon Io is like. Extremely inhospitable, unstable, radioactive, erupting with volcanic lava, splashing sulfur from the depths of its lakes. It has plateaus, ravines, mountains, bodies of water, calderas, faults, and cliffs, just like Earth. However, this is an absolutely dead world, the least suitable for terraforming. But aren't we going to learn even more about this amazing object? There are no planned missions to Io in the near future, but perhaps Earth's scientists will change their minds and send a probe specifically to Io for more detailed study. After all, it offers an excellent opportunity to monitor the conditions that existed on rocky planets at the dawn of time, when something different, more orderly, and less extreme was born out of fiery chaos. Looking at the images shown in this video, do you still consider our neighbor Venus to be the most hellish place in the solar system? Then watch the video again. Is there anywhere else you can see lakes of molten magma where Liechtenstein could easily sink? On which planet's sky does a giant body of a gas Jupiter take the place of its parent star, and inside which celestial body is the pressure so immense that lava constantly tries to break out to the surface? If you have any other options, even remotely similar, feel free to share them in the comments. Well, Earthlings, this isn't the end of the video. There are still some very interesting and truly spectacular episodes ahead of us. But for me to keep delighting you with all the characters from the vastness of the universe, I need your feedback. You can express it quite simply. All you need to do is give this video an electronic like, since we simply don't have any other kinds of likes, and continue the phrase, I know. This way, you'll let us know that we're moving in the right direction. Don't switch channels.